Hello everyone, welcome to Learning Management System, Department of Collegiate and Technical Education. Myself, Sridhar Murthy, Selection Grade Lecturer, Department of Electrical and Electronics Engineering, Government Polytechnic, Chikamagalur. In today's session, we are going to learn the armature winding, the types of armature winding, what is meant by a full pitch winding and fractional pitch winding of an alternator belongs to session number 31 of unit 4 and from the subject DC machines and alternator of third semester. So before going into the today's session, so we will try to recall the what we have learned in the previous session, that is in session number 30. In session number 30, we have learned the major some of the disadvantages of salient pole type rotor. After that, we are going to learn we learned smooth cylindrical type rotor, which is also called as a non-salient pole type rotor. Then we have seen some of the important advantages of cylindrical type rotor and the difference between the salient pole and smooth cylindrical type rotors. Then we have seen the exciter, the function of the exciter, what type of exciter are used in the alternator. So these are the things that we have discussed or learned in the session number 30. In today's session, we are going to learn what is meant by armature winding. Before that, the advantages of having stationary armature and rotating magnetic field. After that one, we are going to learn the armature winding, then the types of armature winding, and what is meant by full pitch winding and the short pitch winding. So these are the topics we are concentrating in today's session. So let us begin. The first one, the advantages of having stationary armature and rotating field system. See, as I told you in some previous sessions, one of the major difference between the DC generator and alternator is that in case of a DC generator, we have a rotating armature and a stationary magnetic system. Whereas in case of an alternator, we are having a stationary armature and a rotating magnetic system. So why we have to go for such a constructional arrangement in case of an alternator? Here are the points. The first point, it is easy to collect the supply of high voltage from a stationary armature. See, in case of a DC generator, as I told you, the armature is rotating. That means the conductors are rotating. Hence, it is quite difficult to collect the voltage generated in the rotating machine rather than from a stationary armature. So in case of an alternator, as the stator, that is the conductors are stationary, it is very easy to collect a very high voltage from the stationary armature. So that is the first main important point why we have to have a stationary armature. The second one, it is easy to insulate stationary armature winding for very high voltage. If the voltage is very high, so then it is very easy to insulate a stationary armature. Why? Because if the armature is rotating, imagine the armature of an alternator is rotating. See, alternator is producing a very high voltage of the order of 11 kV, that is 11,000 volts. Then it is very difficult to insulate such a high voltage winding, because when the armature is rotating, there is a not only there exist a electrical stresses, but also they are subjected to high mechanical stresses. So if the armature is stationary, such mechanical stresses will not be there. Hence, it is very easy to insulate a high voltage winding if it is a stationary. That means in case of a stationary armature, it is very easy to insulate very high voltage windings. Next, third one, if the armature is stationary, we need only two slip rings because the slip rings are necessary to supply the external DC to the magnetic system. We need exciter. Okay. The function of the exciter is to supply the external DC voltage to the to the rotating magnetic system. Okay, as the magnetic system is rotating, how to supply the excitation? The supply of excitation is through a pair of carbon brushes and slip rings. Why we need two slip rings? One for positive and one for negative. Okay, but if the armature is rotating, on the other hand, if the armature is rotating, then we need four slip rings and four brushes. Why we need four slip rings? Because for three phases we need three slip rings, and for neutral we need another slip ring. So obviously four brushes are also required. The cost is more. Hence, in order to avoid that, we have a stationary armature and a rotating magnetic system. So this is the third point. The fourth one, if the armature is stationary, we can accommodate more number of conductors in the stator because the armature is stationary. So hence it is stationary, no question of rotating. Hence we can insert more number of armature conductors. So hence, what is the advantage? We can produce more voltage, or else output of the generator is increased. On the other hand, if the armature is rotating, we cannot insert more number of conductors. Why? Because the arm, if it is rotating, the mass or the weight will increases. So in order to have a mechanical balance, so we cannot insert more number of conductors. So that is the fourth important advantage. The fifth one, see, if the armature is rotating in the alternator, if the armature is rotating, then it is a heavy mass. So hence it is very difficult to rotate a heavy body rather than a lighter body. On the other hand, if the field system is rotating, the field system is having only the poles and a few field windings. So hence the mass is very less, or the weight is very less. Hence rotating a lighter part is more easy compared to the rotating a heavy mass. So this is the another advantage. So the sixth advantage is that the stationary three-phase armature can be directly connected to the load. So no question of connecting the load through the slip rings and through the brushes. So hence, what happens? It is very easy to collect the load to a stationary winding rather than a rotating one. So these are the six main advantages making the stationary armature of an alternator. So these are the most important points. So the first one, let me to repeat once again. What are the advantages of having a stationary armature over a rotating field system? The first one, it is very easy to collect supply of very high voltage from a stationary armature. Second one, it is very easy to insulate a high voltage winding because the absence of mechanical stresses on the insulation. The third point, if the armature is stationary, we need only two slip rings and two brushes. If the armature is rotating, we need four slip rings and four brushes. Why we need four? Four because for the three phases we need three slip rings, and for neutral we need another slip ring, because as I told you in the previous session, the normally the stator winding is star connected. So because of that we need four slip rings and four carbon brushes. If it is a rotating magnetic field, we need only two slip rings, one for positive, one for negative, and only two brushes. So that is the another advantage. The fourth one is we can place a more conductor in a stationary armature rather than a rotating armature. That is the fourth advantage. The fifth advantage is if the armature is stationary, hence it is only we have to rotate only a lighter part. That is, the field system is a lighter part which can be rotated very easily. And the last one is stationary three-phase armature can be directly connected to the load. Okay, so in case of a DC generator, as the armature is rotating, the rotating armature has to connect to a stationary load, which is quite difficult and complicated one. So hence, in case of an alternator, if the armature is stationary, so definitely we can directly connect a stationary load to a stationary armature. So these are the important advantages which we get if we make the armature of an alternator stationary. Or else, if we make the stationary armature and rotating magnetic field, these are the advantages that we can have. So after this, we are move on to the most important part of alternator is the armature winding. In general, what is meant by a winding? The winding is nothing but the systematic arrangement of various conductors in the slots of the armature is the general definition of what is meant by a winding. That means we cannot place all the conductors wherever we want. So there is a systematic procedure to place all the conductors in the various slots of the armature. So that procedure or that process of placing the various conductors in the various slots of the armature or the stator is what is called as an armature winding. And that is the definition. The armature winding is defined as the systematic arrangement of various conductor placed or housed and protected within the armature or stator slots and are connected properly is called as armature winding. Okay. See, these windings are arranged in the slots of the armature or in the slots of the stator. Next, in case of a DC machine, the what type of winding we are using? In case of a DC winding, we have learned in unit number 1, that is the types of winding of DC generator. There we have seen basically two types of windings, closed winding and open winding. So closed winding is also called as a DC winding. DC winding is called as closed winding. Why? Because the winding is closed at the commutator segments. Because of the presence of commutator segment, the winding is closed on itself. Hence, DC winding is also called as a closed winding. But whereas in case of a alternator, the windings are not open. Okay, the windings are open. Sorry, the windings are open, and in case of a DC generator, the windings are closed. So hence, alternator winding is also called as a open coil winding. Open coil winding, which will gives a star connection. Okay, usually the winding of this, the stator winding of an alternator is star connected. Why it has to be connected in star? That already discussed in the previous session. Okay. Now this is regarding introduction towards the what is meant by an armature, a winding of an alternator. Next, we have a different types of armature windings like that of a DC generator. So, but in DC generator, we have only the lap winding and a wave winding. That's it. But in case of a alternator, the types of winding depending upon the type of machine itself. If it is a single phase machine, we have single phase winding. If it is a three phase or if it is a polyphase alternator, then we have to go for a polyphase winding or three phase winding. Okay, that is the first one. Second one, it may be a concentrated winding or it may be a distributed winding. In case of an alternator, the conductors are concentrated in one slot or may be distributed in various slots. So the major disadvantage of having a concentrated winding is that in case of a concentrated winding, maybe we get a more quantity of induced voltage, but higher order harmonics will changes the wave shape of the sine wave. So hence, in order to avoid that, we will go for a distributed winding. Next one, it may be a half coil winding or it may be a whole coil winding. Next, it may be a single layer winding or it may be a double layer winding. So it may be a lap winding or it may be a wave winding or it may be a concentric or the spiral winding. It may be a full pitch coil winding and a fractional pitch coil winding. So these are the different types of armature windings of an alternator. So here, as per the syllabus, we have only the different types of, we have to list the types of armature windings. So hence, we will move on to the next slide, that is what is meant by a full pitch winding. See, these some of the things that we have already learned in DC machine armature winding, that is in unit number 1. So there we have discussing the pole pitch. What is meant by pole pitch? First, let us see what is meant by a pole pitch. See, in case of a in case of See, as we know that the voltage induced in the armature is always AC. Okay, is always AC. Is always AC, which is like this, isn't it? Positive half cycle is induced when the conductor passes over N pole. Similarly, the negative half cycle is induced when the conductor passes over south pole. Okay, that means one cycle of, in order to induce one cycle of EMF, we need a pair of poles. Okay, we need a pair of poles, that is, we need two poles. One is for north pole and another is south pole. So by having a pair of poles, we can produce one cycle. Okay, then what is meant by pole pitch? What is meant by one pole pitch means, see, this is one pole. One pole is responsible for one inducing of the 180 degree of voltage, inducing of 180 degree of 180 degree of voltage. Another pole is responsible for another 180 degree of induced voltage. So including both, we can have 360 degree. So that means then one pole pitch is nothing but 180 degree electrical. Here we are using one more term, what is meant by electrical degrees. That means there is a in rotating electrical machines, we often use electrical degrees and mechanical degrees. Then what is the difference between these electrical degrees and mechanical degrees? See, if it is a two-pole machine, in one rotation, okay, in one rotation, that is in 360 degree, one cycle of EMF will be induced. One cycle of EMF means 360 degree. That means electrically 360 degree and mechanically it is also 360 degree. That means if it is a two-pole machine, in one rotation of the armature coil, we get one cycle of EMF induced. Then electrically it is 360 degree, mechanically it is also 360 degree. Suppose if it is a four-pole machine, we can produce two cycle of EMF in one rotation. Two cycle of EMF will be induced. When two cycles means 360 degree plus 360 degree. So we get 720 degree electrical, but still in one rotation, mechanical it is still 360 degree. On the other hand, if it is a six-pole machine, we can get three cycles of EMF induced, three cycles. That means 360 degree into 3. Okay, we get 1080 degree in one rotation. Electrically 1080 degree, but still mechanically 360 degree. Got it? That means, let me to repeat once again, what is I am explaining, what is the difference between electrical degrees and mechanical degrees in a electrical machines. See, if it is a two-pole machine, we can produce one cycle of EMF in one rotation. One cycle means 360 degree electrical, that is electrical degrees. Then what is mechanical degrees? Still it is a 360 degree. That means in case of a two-pole machine, both electrical degrees and mechanical degrees are same. What happens if it is a four-pole machine? If it is a four-pole machine, in one rotation, we get two cycles of EMF induced. Two cycle means 720 degree. 720 degree electrical, but still mechanically 360 degree. Similarly for six pole, it is three cycles, which is nothing but 1080 degree, that is 360 degree into 3, that is 1080 degree, still mechanically it is 360 degree. From this explanation, we can conclude that there is a formula between electrical degrees and mechanical degrees of rotating electrical machines. That means if theta is the angle of rotation, then electrical degrees theta E is equal to pair of poles into what? Into mechanical degrees. Theta M is mechanical degrees, theta is E is electrical degrees. Okay. Then what is meant by pair of poles? P by 2 into theta M. Theta M can be written as always it is 360 degree. So this is the relationship between what is meant by electrical degrees and mechanical degrees. Okay. So if it is a 6 pole, it is nothing but 3 pairs. For example, if you take this one, if we apply this formula to this condition, we get what? Electrical degrees is equal to 6 poles means what? 6 poles means 3 pairs. Okay. 3 pairs. Okay. Are 6 divided by 2 into 360 degree, we get 1080 degree. So this concept is very important while understanding the relationship between electrical degrees and mechanical degrees. So finally, we can say what is meant by one pole pitch. One pole pitch is nothing but what? 180 degree, not mechanical. It is electrical because it is a electrical sine wave. Okay. So one pole is responsible for half cycle. Half cycle means 180 degree. So that is nothing but one pole pitch is always equal to 180 degree, and this is the most important concept while understanding the pole pitch or the full pitch winding and fractional pitch winding. Hope you got this equation. Next. So what is meant by a full pitch winding? If the coil span, then what is meant by coil span? The coil span is nothing but what? The coil span is the distance between the two sides of a coil. This is one coil. Imagine this is the winding. Okay. So this is the winding. Then this is coil number 1. This is second coil. A coil is having two sides. Then the distance between the two sides of a coil is called as coil span. Is called as a coil span. Remember, if this coil span is always equal to one pole pitch. Okay. If the coil span is always equal to one pole pitch means what? 180 degree, 180 electrical degrees, 180 electrical degrees. Then the winding is called as full pitched winding. Winding is called as full pitched winding. Okay. So then what is its meaning? The meaning of this full pitch winding is that the meaning of the full pitch winding is that one. Okay. Observe here. Observe here. If we place, okay, imagine this is North Pole and if it is South Pole, then in case of a full pitch winding, if you place one side of the coil in a slot, okay, in a slot which is under N pole, then its corresponding other side will comes exactly under S pole. Then such winding is called as full pitched winding. Okay, called as full pitched winding. That is, the coil span is equal to 180 degree electrical. That means if we place one side of the coil in one slot under N pole, then its other side exactly comes under S pole. Okay, so such type of winding are called as full pitched winding. Okay, see the definition of full pitched winding. The coils having a span, see, observe here. If the coils having a span which is equal to one pole pitch means 180 electrical degrees. 180 electrical degrees. That means in a winding, if the coil span is equal to one pole pitch, then the winding is called as full pitched winding. So that means when the two coils sides are forming a complete coil of winding or 180 degree electrical space, then the winding is called as full pitched winding. Okay. See, let us take the example of a full pitched winding. Okay, see, observe here. Okay, see, observe here. So here the dotted line will don't concentrate on dotted line. We concentrate on only the thick line. So this shows full pitch winding. Okay, imagine there are 24 slots. Imagine there are 24 slots and it is a 4-pole machine. Then what is the pole pitch? Okay, then what is the pole pitch? Pole pitch is equal to number of slots per pole. The number of slots is nothing but what? The 24 slots. It is a 4-pole machine. Then it is 6 slots. So pole pitch is equal to 6. That means what? If the one coil side is placed in slot number 1, then 1 plus 6 is equal to 7. The other side of the same coil must be placed in slot number 7. Then the winding is called as a full pitched winding. Then if this slot comes under N pole, exactly this slot comes under S pole. Such winding is called as a full pitched winding. Let us see the example. Okay, so let us see this example. That means if it is a 24 slots 4-pole machine, then the full pitch is 24 by 4, that is equal to 6. That means if there is a distance of what is 7 minus 1. Okay, 7 minus 1 is equal to 6. That means if you place one coil in slot number 1, then its other end should be placed in slot number 7. Then what happens? If the voltage induced in slot number 1 is 10 volts, for example, imagine is 10 volts and the voltage induced in slot number 7 is also 10 volts, then total induced EMF is 10 plus 10, that is equal to 20 volts. That means if in general, if the voltage induced in slot number 1 is marked as ES and other side is also ES, then what is the total induced EMF? If you draw the vector, that means if this is slot number 1 voltage, which is nothing but ES, and the other slot number 7 induced voltage is in the same line. Why it is in the same line? Slot number 7. Why? Because the angle is 180 electrical degrees. Okay, 180 electrical degrees. So hence both will comes in the same line. Then what is the total voltage? The total induced voltage is the arithmetic sum, that is equal to ES plus ES, which is equal to 2 times induced voltage. So this is the concept regarding full pitched winding. What is the net voltage induced in both the slots? It is arithmetic sum of the induced voltage in each slots. Okay, so let's see. This is what we have mentioned over here. Okay, so the EMF induced, consider this figure B. EMF induced in one slot number 1 is ES. As I told you, this is the voltage ES induced in slot number 7. Then the total induced voltage is 2 times ES. So that example is mentioned here again. So these are the concept regarding the full pitched winding. Hence, in case of a full pitched winding, we got more induced EMF. Okay, but the major drawback is that though we have more voltage induced in full pitched winding, but here higher order harmonics are superimposed on the fundamental wave. Hence, the wave shape will be distorted. That is the major drawback of full pitched winding. That will be seen in future slides. So the total, as I told you, the total EMF induced is more. Then what is meant by short pitched winding? As I told you earlier, see, if you take the same example, suppose 24 slots, 4-pole machine, then pole pitch, is equal to 6. For a full pitched winding, the coil span should be equal to 6 slots, or else it is 180 degree. But this is North Pole, and exactly this is under South Pole. So this is under North Pole. On the other hand, if in a winding, if the coil side is placed in this slot and its other end is placed, okay, supposed to be placed over here. If it is a full pitched winding, instead of placing there, I place it here. Okay, that means there is a short of one slot. Okay, that means the coil span, is less than 180 electrical degrees. Then the winding is called as short pitched winding. This is for full pitched winding. Okay, such windings are called as short pitched winding. Why we have to go for short pitched winding? As I told you in the previous slide, in case of a full pitch winding, even though we got more voltage, but the pure sine wave is distorted due to superimposing of higher order harmonics. So in order to avoid the harmonics, higher order harmonics, we get a short, okay, we get a short pitched coils. So such windings are called as short pitched windings. Okay, such windings are called as short pitched windings. Short pitched winding. Let us see. If the coil span of the winding is less than 180 electrical degrees, then it is known as a short pitched winding. So mentioned here, take the same example. Instead of connecting it to the slot number 7, we have connected to the slot number 6. That means there is a short of one slot. That means there is a short by an angle of alpha. Okay, so such windings are called as short pitched windings. Now what happens? See, in case of a full pitch winding, what is the vector diagram? So this is the voltage induced in slot number 1. Then again, the same voltage is induced in, this is slot number 1, this is slot number 2. Because they are displaced by an angle of 180 electrical degrees, because it is a full pitched winding. Then total induced voltage is 2 times ES. But in case of a short pitched winding, if this is the voltage ES is induced in slot number 1, then there is a short of by an angle of alpha degree. So if it is here, we had a full pitched winding, that is 180 degree. So 180 minus alpha. Okay, so by that angle, so by short by an angle of alpha, the other slot is placed. So this is the voltage induced in the slot number 2. Then what is the total induced voltage? It is not arithmetic sum. Then it is vector sum. It is a vector sum. Okay, so this ES plus CS, you can construct a parallelogram and you can find out what is the net voltage. That is ER is a vector sum of ES and ES. Okay, so it is a vector sum. Here it is in full pitched winding, it is arithmetic sum. So hence the net voltage induced in a short pitch winding is less. But what is the advantage? The advantage is we get a pure sine wave. So this is regarding the short pitch. This is regarding the short pitch winding. Okay, let us see. So as in figure D, here the EMF induced in coil side is not in phase. See, it is not in phase. It is, there is a phase difference by an angle of alpha. So hence the total resultant EMF is the vector sum. So as already I told you. Okay, so hence in short pitched winding, induced EMF is less than the EMF induced in a full pitch winding under the same condition. Okay, the same example, we have taken the same example. So this is regarding the short pitched winding. So dear students, this is the points or important topics we learned in this session. So let me to summarize once again. So in this session, we have learned about the advantages of having a stationary armature and a rotating magnetic field. So important 6 advantages are there. So because of those advantages, we can it is very beneficial to have a stationary armature and a rotating magnetic field. Then we learned what is the basic definition of an armature or alternator winding, and after that we have seen different types of windings, different types of alternator windings. Okay, and then we have seen what is meant by full pitched winding and what is meant by short pitched winding. So before that we have seen the relationship between electrical degrees and mechanical degrees. So that's all for today's session, and let us learn what are the expected multiple choice questions based on this session or MCQs. The first one, if the coil side in one slot is connected to a coil side in another slot, which is one pole pitch distance. Observe here, if the one coil is placed in one pole, then its other side is exactly placed in the other slot. Okay. So the coil span is, here it is mentioned as what? The coil span is one pole pitch. So if the coil in a winding, if the coil span is equal to one pole pitch, we call full pitched winding. If it is less than one pole pitch, we call it as a short pitched winding. Let us see the options: short pitched, full pitched, concentrated, distributed. The answer is full pitched winding. So full pitched winding is the right answer because the coil span is equal to one pole pitch. The second question, in practice, which combination of armature winding is preferred for the alternator? Okay, so which type of winding is used? So as I told you in the previous slides, if we go for a concentrated winding, more EMF will be induced, but the waveform is deviated from pure sine wave. And if it is a full pitched winding, then also we get that one of the advantage is we get more voltage, but waveform is distorted. Okay, let us see what are the options. Single layer, full pitched and concentrated; single layer, short pitched, distributed; double layer, full pitched, concentrated; double layer, short pitched and distributed. So the answer is double layer, short pitched, distributed winding. See, that is the right answer. The option D is the right one. As I told you, double layer means more conductor, more voltage will be induced. Short pitched means the waveform is pure. Distributed means obviously the waveform is also pure. But the another most important advantage of having a short pitched winding is there is a large saving of copper, and mechanically the coil is very strong. So hence, because of all these things, we have to go for a short pitched and a distributed wire type with double layer. The next one, due to short pitch, the induced EMF will get what? Let's see the options: reduced, increased, remain same, none of the above. So short pitch, by having a short pitch winding, the induced voltage will get reduced. Option A is the right answer. Next, question number 4. If the coil span of the winding is less than 180 degree, almost similar to the first multiple choice question, then the winding is known as, obviously it is a short pitched winding. Then in short pitched winding, the resultant EMF is what? In short pitched winding, in a full pitched winding, the net voltage is arithmetic sum. But in case of a short pitched winding, the resultant voltage is vector sum. See, observe here. So it is a vector sum of the EMF induced in each coil sides. So next question is, one pole pitch is always equal to, I have given the example, one pole pitch is nothing but 180 degree. Okay, so that is nothing but 180 electrical degrees. So that's all the most expected multiple choice questions from this session. And this is the reference material, and this is my state LMS team for the subject DC machines and alternators. So this is our state team. Hope, dear students, you are all enjoying the learning management system and have a happy e-learning. Thank you, one and all.